out, I want to start by defining something called a unit circle. So when we say a unit circle, that's a circle that's centered at the origin with radius of 1 unit. So what we're going to do with our unit circle is we're going to observe that points along this unit circle are going to represent solutions to things like cosine theta and sine theta. Everybody okay with this idea? If this radius is 1, and this point is x over y, I literally get that cosine is going to be x over 1, and then sine is going to be y over 1. So on the unit circle, this point xy is really the point cosine theta comma sine theta. So what the unit circle is going to do is it's going to be like a shortcut for us to calculate sines and cosines, as we're already going to have that kind of taken care of for us. So let's drop in that blank unit circle. So if you guys can take a look at the sheet that I passed out just a moment ago to you guys, we're going to fill in this unit circle together. If you feel like you made a mistake, or if it's like you look at this and be like, yo, my penmanship is such a disaster, I can't read any of this afterwards, I have up on PowerSchool a blank copy of this that if you wanted to print out and redo neater, that's fine. And I have a one that I've typed in the values for on PowerSchool as well, that I haven't posted them yet, but I will here during community time or something. Matt? You would be able to use this on the test. Okay. All right. So what we're going to do is all of these angles that we can find exact values for, i.e. that when we draw a reference triangle, we end up with like a 30, 60, 90 or 45, 45, 90 triangle. We're going to record those values here on our unit circle. So I'm going to first start by writing down the degree measures. So 0 degrees, 30 degrees, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, that's 240, sorry, 225. So the pattern that you should be seeing is the skinny slices of the pizza are 15 degrees, and the bigger slices are 30 degrees. Okay with that idea? So our big slices are 30-degree slices, and the skinny slices are 15-degree slices. That'll help. If you're not sure what the one is, you can figure if you know what the previous one is, you can just do a little bit of counting, right? That's 330. 360 is the same as 0. Exactly right. Yep, those two angles are coterminal to each other. 120. Yep, remember it's a big slice, so you do 90 plus 30 is 120. Okay. So next to all of these, let's write in their radian measures. So 0 degrees is 0 radians. 30 degrees is pi over 6. 45 is pi over 4. And 60 is pi over 3. 90 is pi over 2. 120 is 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. 180 is pi. 210 is 7 pi over 6. 215 is 5 pi over 4. 225, excuse me. That's a 5. And then 240 is 4 pi over 3. And then we have 3 pi over 2. And then 5 pi over 3. And then we have 7 pi over 4. And 11 pi over 6. Okay. So let's fill in the points for these quadrants. So this point here is going to have what coordinates if the radius of our circle is 1? It would be the point 1, 0, right? How about up at 90 degrees? What would that point be? 0, 1. How about the point at 180 degrees? Negative 1, 0. And then down at 270 would be 0, negative 1. Is everybody okay with that idea? So let's draw in our, I'm just going to draw our 30, 60, 90 triangle here real quick. So if I drew in my reference triangle at this first 30-degree angle, I would get that opposite is 2x, or is x, and then hypotenuse is 2x, so sine is 1 over 2. And cosine is adjacent over opposite, so that would be square root 3 over 2. And now everywhere where when I draw my reference triangle I make a 30-degree angle with the x-axis is going to have coordinates square root 3 over 2 comma 1 over 2, which is the signs being different. So in the second quadrant that's here, and in the third quadrant that's there, and in the fourth quadrant that's there, because when I draw my vertical line back to the x-axis, I would be making a 30-degree angle in each of those spots. So in the second quadrant, I know the x is negative, so I'm going to have negative square root 3 over 2, 1/2. In the third quadrant, I know x and y are negative, so I'd have square root of 3 over 2, or negative square root of 3 over 2, and then negative 1/2. And in the fourth quadrant, the y-coordinate is negative, so positive square root 3 over 2, but negative 1/2. Now I'm going to do the 60-degree angles. So I'm talking about this angle, this angle, this angle, and this angle. All of those spots, when I draw my reference triangle, I'd make a 60-degree angle relative to the x-axis. So here, if I'm looking at the 60, cosine is adjacent over hypotenuse, so that would be 1/2. And sine is opposite over hypotenuse, so that would be square root 3 over 2. And now I'm just going to go around to those other 3 points and fill in the values, changing the signs appropriately depending on the quadrant that the point is in. So in the second quadrant, the x is negative, but the y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, the x is positive, but the y is negative. Now I'm going to do the angles that make 45 degrees when I draw my vertical back to the x-axis. So that's just the 4 that are remaining. So if I do that, looking at 45 degrees, cosine is adjacent over hypotenuse. So that, when I rationalize, would be square root 2 over 2. And sine would also be square root 2 over 2. So if I move around to the second quadrant, the x's are negative, but the y's are positive. If I go to the third quadrant, the x's are negative and the y's are negative. And if I go to the fourth quadrant, the x's are positive, but the y's are negative. So what we're going to say here is now on the unit circle, cosine theta is going to be x, sine theta is y, tangent theta is going to be y over x, secant theta is 1 over x, cosecant theta is 1 over y, and cotangent theta is x over y. So notice these are the same definitions we gave for the point definition, except we're setting r equals 1. So this is the same definition we did before, we just set r to be 1. Because in the unit circle, the radius is 1. The hypotenuse of our triangle is always the radius, so all of the r's just turned into 1. That's why this looks a little bit different. Okay, so using the unit circle, let's find the values for, say, sine 120. No, you can do this on your notes or on the same sheet as this unit circle thing. That's whatever, it doesn't matter to me. So if I want to go find sine of 120, I locate the 120 degree angle on my unit circle. So that's dealing with this point. Everybody agree with that? I know that sine is the y, so I know that sine of 120 is square root 3 over 2. And I'm done. So what this unit circle is doing is it's allowing us to kind of shortcut around what we had to do, or what we were doing in those examples at the end, or those last couple of problems from last night's homework, right? So if I do tan of 5 pi over 4, what I'm going to do is I'm going to locate 5 pi over 4 on the unit circle. That's right here. So we're going to be dealing with this point. Everybody okay with that? And tangent, we know, is y over x. So it's going to be negative root 2 over 2 over negative root 2 over 2. But that just comes out to 1. What if I ask us to do the cosecant of 390? Notice 390 degrees is not one of the angles on my unit circle. However, if I try to draw the 390 degree angle, 90, 180, 270, 360, and then 30 more is 390, right? So I can just use 30 degrees, the angle that is coterminal to 390, to compute this. So the point associated with 30 degrees is here. And I know that cosecant is 1 over y. The y in our case is 1/2. So I have then cosecant of 390 is 1 over 1/2, which is just 2. Okay with that idea? All right. You guys can finish the homework then. That's 55 to 60. I'll also post the review to PowerSchool. When we meet next, we'll talk about this homework in the review and what to expect for the Chapter 2 test.